Hello, statistical scholars, and welcome to a fun example of doing some statistics from things from Chapter 7. So we're going to be doing normal probability today and calculating a few things. So I'm going to show you how to do this using a standard normal calculator and a standard normal table today. So a little bit different from the other video from Chapter 7. So the first thing I'm actually going to do is draw a picture of what's happening for number 9. So I'm doing a standard normal model. So as we note that we're going to look at the variable as we don't use x for standard normal. Sorry about that. We use c, and we say that it's normally distributed with mean 0 and standard deviation 1. So as I begin this first example, I note that I want to look at the probability that z is going to be greater than negative 1.65. So I'm just going to go ahead and start drawing this standard normal better than I just did. Come on, draw straight. That's not doing so well. Hold on, let me flip this over. Yes, auto rotate is great when it works. I hate the lasso eraser. I wish it wouldn't do that. Okay. Yes, I'm okay with that, Windows. Alright, so straight line. I'm going to draw a fairly good normal curve here. Normal curve, normal curve. No, we're freezing. That's great. There. Sorry about that. Oh, it's picking up. Keeps picking up my wrist instead of my hand. You don't need to know this. Man, I wish I knew how to edit this out. Come on, curve. Here we go. Okay, so my mean is at 0. As we noted here, which is at the center of the distribution. I'm going to draw some... I'm having some hard time today getting this to react to me well. Okay, we're going to draw with touch. It's not working. So let's draw a couple standard deviations in here. So remember, if I go out 1 in each direction, so I'm going up by 1 because that's my standard deviation, going down by 1, 2, and then 3. And what I'm interested in figuring out what's going on for a specific value at negative 1.65. So I'm looking at the probability that z is greater than negative 1.65. So I'm going to shade in what that looks like. So I'm looking at all the stuff to the right of negative 1.65, all of that probability. So that's that value. Okay, now there's a couple different ways I could do this. I can use the standard normal table, which if I go to the table, woohoo! Couple of things. You notice the table always represents area to the left, which means when I'm doing this, I'm doing to the scores that are values that are less than the particular score you're looking at, which means that it won't match what we're doing right now. It'll give us the opposite of it, but we can figure that out real quick. And if you remember, our score was negative 1.65. So if I go on to the table, negative 1.6, there's the first part of the score, and then notice along the top there's there's the second decimal place, or the thousandths place, and mine is a 0.05, so I want to be looking in this column. Negative 1.6, 0, 1, 2, 3, 4, 5. That's my probability that I'm interested in, the 0.04947. And that's the one I'm going to subtract to get what I've got here. Because remember, this is giving me area to the left, but I want area to the right. So if I use the table, I got to do 1 minus the probability that z is less than negative 1.65, which would be 1 minus the value I got off the table, 0.04947. And if you do that calculation, you get 0.9505. 3. Which is a little more accurate than what I put in your answer key, so fun with that. The other way you could do this is using the calculator. I think I'm going to reserve the calculator for the one. Eraser's working well today. Let's do B with the calculator. So for B, we'll scroll down a little bit further. We're going to, once again, oh, that's like the worst one I've drawn in a long time. Good times here. I'm just going to put 2 standard deviations in here. So here, I want to find the probability that my z-score is going to be less than negative 1.25. Now this would have been actually easier to find on the table than what I did, so it's really great that I'm doing this on the calculator now instead of the table. So I want to figure out, there's about where negative 1.25 is, like 1.25, and then I want to look at the stuff less than it, so I'm looking at the area to the left. Okay, and now let's pull up our calculator and see how to do this on there. Okay, move that more towards center mass. Oh, it's not gonna let me. That's fine. Okay, if we turn on the calculator, it hopefully works. No, we're not. No? Okay, there we go. Pretty. We're going to actually go to the distribution key, which is right here, where you'll find all of your probability distributions. So we're going to hit second vars. This is not working. Well, there goes that idea. Hold on. Let me try turning up the contrast to see if that makes a difference. It does nothing. Okay, guess I'm not doing it that way. All right, well, let's look this up on the table. Negative 1.25. Where's my table at? You guys see I was shopping earlier. That's fun. Negative 1.2, and then 1, 2, 3, 4. Oh, I forgot 0. 1, 2, 3, 4, 5. 10, right there. 10, 0.10565. That's about where we're at. So about 0.0565 is my probability. Okay, now let's take a look at C. So here I want to find the probability that I'm between 1.05 and 1.95. So I'm going to think about this in 2 ways. So if I draw the picture of what's happening, here's my 0. I'll put my 2 values on here, 1.05 and 1.95, and I've exaggerated this a little bit to make it a little easier to read. And I'm looking at the area in between them. So since I'm using the table, which only does area to the left, okay, I want to think about it as like, oh, so if I put this, if I look up this value in the table, it would only give me the area left, which would be all of this stuff back here. And if I look up the value 1.95 in the table, it would give me all the stuff back here, right? But I want the stuff in between them, so I need to take the higher one and subtract the lower one to give me this. So I'm actually going to do the probability that C is less than 1.95, and then subtract from it the probability that C is less than 1.05. So I'm going to have to look up these 2 values in the table, bring them out here, and then subtract them to come up with the correct probability. So let's pull up our table again. Now I got to go to the positive side. 1.95, 0, 1, 2, 3, 4, 5. There is my first probability, the larger one, which it's very large, so that makes sense. And it's 0.97441. And I'm going to subtract from it 1.05. So there's 1.0. 0, 1, 2, 3, 4, 5. It's in the same column. That's kind of nice and easy to read. 0.85314. I'm going to go back and write those down. 0.97441. 441.85314. I'm going to subtract those two and get 0.12127. Again, slightly more accurate than what we've done previously. Okay, so I need to insert some space here. Sorry. Ah, no, I didn't want to zoom in, you devil. Oh, this is going so well. Typing tool, insert space. Nope, I have to enter a bunch. 2 seconds. Oh, I hate it does that when I leave tablet mode. Oh, this has got to be confusing to watch. I wish I had editing skills. One of you, point me towards how to learn how to edit. No, not a new text box. I want the one I'm existing in. Oh, this is just going so well. I want to move number 10 down. Thank you for making this worse than it needed to be. Okay. Now let's do D! Last but not leastly and slightly more beastly. So I'm worried that the reason why D looks a little bit difficult to use, you don't remember how absolute values work. So I'm looking at all the values that are less than or equal to 0.6 when I make them positive. That also means it includes everything that when I make it positive, if it's negative, oh my god, is smaller than 0.6. So if you're thinking about that visually, I'm looking around 0. Oh boy. Looking around 0. And all the stuff that's smaller than 0.6. But I need also all the stuff that when I make it positive, it becomes smaller than 0.6. So like negative 0.5 would be there, and so would negative 0.1 and negative 0.3 and negative 0.2. All would be in there, but like negative 0.7 wouldn't be because when you make it positive, it would be bigger than 0.6. So it's all the way up to and including negative 0.6. So that's the area we're interested in this time. So if we translate that into a probability statement, I would think of this as, hey, I want the z's that are between negative 0.6 and positive 0.6. And I'm going to do something that's going to be a little bit different from what I did last time. Since this is symmetric, I can use the symmetry of the distribution to figure out what's going on here. So instead, I'm going to do half. I'm just going to figure out this half and then double it. Okay? And that's going to be a little bit more complicated, but hey, never hurts to try something different. So I know that half of the distribution in total is 0.5. So I'm going to double what I come up with here. I know half the distribution is 0.5, and I know that if I look up negative 0.6 on the table, that will give me this area here, so that's what I'm going to subtract. Okay, now let's look that up on the table, and let's finish these parentheses so it's clear what I'm doing. And I'm doubling to account for the yellow parts, so that my yellow and reddish pink part are the same. So I'm doubling after I subtract. Let's look it up on the table. Oh boy, on this version of the table works great. So I need the negative side of the table, which is up here, and I need negative 0.6. I bet you're watching me scroll has been like super helpful for those of you who get dizzy. So it's negative 0.2. I'm going to be subtracting, not negative 2.7425. One thing worth noting is that probabilities are never negative. So if you're doing one of your calculations and you come up with something negative, you have definitely made a mistake somewhere, and that's not good. Okay, we're going to subtract that and get 0.22575. And then I'm going to double it to come up with 0.4515, which is a little bit, oh, that's exactly what I got in the other one. So, fun times. Cool. Let's see. I think I'm going to do the first part of number 10. I'm going to just do one of them. And then I'm going to stop this recording and finish number 10 on a calculator that works. But let me try the calculator again without using the touch screen and see if that works a little better. No, I don't want it. I want it over here. Okay, fine. Don't listen to me. I'm not sure why this isn't working. Okay. Well, I guess I'm going to try it with a non-touchscreen computer then, with the calculator. So, start with touch. So when I think about this, I'm doing the opposite of what I've done before. So if you look at my previous examples, I've always taken z-score, shaded my probability, found my probability based on the z-score. We're going to go backwards now. We're going to take a particular probability and come up with the z-score associated with it. So I want the highest 25%. So I want this area right here to be 0.25. So if you think about it, what I'm trying to do is I'm trying to find the stuff, the score, I don't know, the value, so that when this value, this cutoff value, so that when I look at all the z's above it, I get 0.25. Now, I'm actually going to flip the script on this since my table only does stuff to the left. Darn. I'm actually instead going to look at the probability that when I'm smaller than that questionable value, I get 0.75, because the law of total probability tells us that in total, all of the area under the curve must be 1, so this must be 0.75, because the tail area here that I was interested in is 0.25 when you consider that cutoff value that I don't know. So I got to look up question mark. So instead of doing the table last and getting a probability, I do the table first now because I'm going opposites. So I start by trying to find something close to 0.75. So I'm going to look in the table in the probabilities for 0.75. So at 0 is exactly the halfway mark, so I should expect it to be bigger than that. Let's see, 0.742, that looks pretty close. So let's look around it and see if I can find something that's close to 0.75. Ooh, that's pretty good. So you might ask yourself, oh, should I use 0.748 or 0.751? Always pick the one that is closer. So since this is 1/1000ths off versus 2/1000ths off, this one's going to be closer. So I'm going to be using this probability. So I look up the score that goes with it. So I'll look down the row, 0.6, and then look up the column, 8. So the score I'm interested in is 0.68. Obviously, if you do this with technology, you're going to get a more accurate number than what I just got. So the z I want to have as my cutoff value is 0.68. Okay, so I'm going to save this and come back and show you how to do this on a calculator for the rest of these. And the middle 70% is the hardest one to do, to be honest. And that's the easiest to do on Minitab. So if you're like, oh, D sucks. Well, D is easiest to do on Minitab, so that's exactly how I'm going to do it. Fun times.